You're getting sleepy. Very sleepy. Just keep your eyes on... I got this little guy in a store in Berlin, Germany, my favorite city in the world. The store had all kinds of like artsy things in it, and it was really cool, but some of the stuff looked like it could be low quality, so I was taking kind of a chance when I bought this, and I probably overspent. It was about $25. It's not too bad for a little speaker like this, but as it turned out, it's a little gem. There are a lot of things I like about this speaker. One, the Bluetooth connected flawlessly and immediately to my cell phone, and that's a problem I've had a lot with my cell phone, so that was definitely a big plus. The sound quality is pretty good. I mean, obviously you have to manage your expectations here. It's really small. It's not going to be audiophile quality, but I was able to turn this up fairly loud. I like to use it when I'm in the shower, and so to get over the shower noise, I have to turn it up pretty loud, and I haven't noticed any real distortion in it. Another thing I really like is when you plug it in, it just works off of the power. So I had this thing running for like 12 hours and it was going along just fine. I had a cell phone once that just ran off the battery, and so when the battery died, you plug it in, it still didn't work. It had to wait for the battery to charge, you know, so this doesn't do that. And in fact, I took a half-hour break or so to go to lunch, and when I was done with my 12-hour day, it was charged. So all benefits. Plus, I mean, look, I mean, yeah, my wife thinks it's kind of cute. So. Enter stage right, this guy. This is a tweeter out of my car. I blew a speaker in my car, and so when I bought replacements for it, it came with new tweeters as well, and that left me with 2 good tweeters. I think. Problem is I can't remember. I can't remember if one of the tweeters was blown or not, so I'll find out during the making of this video, apparently. What the idea is on a lot of these videos, not only is to show you something different or just what I'm doing that's kind of cool, but to get rid of some of the junk laying around my house, and this is one of them, so I hope that other one really works. There's a lot of information here, and a lot of it is stuff you won't find in other videos, as I like to do. So why don't you join me in the kitchen? I'm going to make a cup of tea. This could take a while. As usual, I went to the internet to do my research, and I watched a couple of YouTube videos, and what I found is when it comes to speakers like this, it's probably better just to buy them. So what did float to the surface are these boards. These are stereo amplified boards with Bluetooth built into them. That would make the project rather simple. Both of these seem to have pretty good reviews and comments online. They're dirt cheap. This one was $14. I think this one was $15. And it would make the project really easy. But that means, as you can see, that I'm going to have to increase the size of my project. And I figured if I'm going to increase the size of my project, well, I might as well add a slightly larger speaker. So I thought I would still use my little tweeter, but I'd also use some kind of a mid-range speaker to go with it and get increased sound. So I've gone up in size from something like this to something the size of maybe a softball or so. The plan was pretty simple. Put the tweeter on the left channel and put the mid-range on the right channel. Done. And that's when I realized that that isn't going to work. So you see, stereo signals are not the same left and right. Should be kind of obvious, otherwise it would just be mono with 2 different channels. That means if I put the tweeter on the left side, then I'm only going to be tweeting the left channel tweetable stuff, and if I put the mid-range on the other side, the same thing's going to happen with mid-range. So that means I really need a mono amplifier. So naturally I just ditched everything I was doing to this point, went online, looked for a mono Bluetooth amplifier, and of course I only found 2. One, I think it was on Amazon, had no reviews, no comments, and I couldn't find anybody that had actually used it to determine if it was any good. It was also about $4 more expensive than the stereo ones I'd bought before. The other one was about 3 times as expensive. I assume it was higher quality. It was bought at it was listed at a place called Parts Express, which is where I bought the speakers. And I think this is where a lot of people get these kind of items that are, you know, higher quality. And like I said, I got the speakers there, and I hope they're good quality. All things being equal, stereo should be better than mono, right? So there was one other option, bridging. Well, I knew nothing about bridging an amplifier, so as usual I went to the internet, and there I found that most people are trying to bridge amplifiers to produce more power, usually to a subwoofer or something. That's not what I was really trying to do, but I seem to recall somewhere in my research that said you can't just bridge any amplifier, you have to make sure it's a bridgeable one. So I went and looked, and it turns out it doesn't seem like these little boards are bridgeable based on the chip. I couldn't find anything about the board itself because it's not sold as a board. It's sold under the name like 7492, the chip that's on here, as if all the components around it didn't make any difference to sound quality, stability, or anything else. When I looked up that chip, it looked like, yeah, you shouldn't bridge it. But people are doing this, so I went on the internet and I looked for somebody who made a mono Bluetooth speaker. And in fact, I found one, the guy who did one that was actually waterproof. So it was pretty cool. If I remember, I'll put it in a link in the description there. So I looked at what he did. He used a 3110 chip. So I went and looked up the 3110, and as it turns out, it doesn't say anywhere that that's bridgeable. So now I don't know, did it blow up 5 minutes after he finished his video, or did it already sound like crap but I couldn't tell because I was listening on my computer? I don't know. It may not be very scientific, but I believe that human intelligence can be put on a scale, at the bottom of which is stupid, and the top of which is genius. I also believe that stupid people walk around all day thinking they're geniuses. I have no idea what geniuses think, probably that the rest of us are stupid. I myself fall somewhere in between these two extremes, just over a line so that I know how stupid I really am. It's kind of a curse. The result of this is that I find myself looking for answers to questions that geniuses already know, and stupid people don't know to ask. It also leads to something I call research fatigue. The more I look up something and I'm not finding what I want, the more tired of the search I get, and eventually I just quit. And the result of that is either, well, one of several actually, either I do something and wing it, and maybe risk blowing something up, or I do something a different way that I know will work, or I just abandon the project altogether. In this case, I decided, you know, I got stereo speakers, or stereo boards, why not just make a stereo Bluetooth speaker? Given that, I've essentially gone from a speaker this big to a speaker this big. Filming this out of order, I apologize, but I wanted to address something that might come up in the comments should anybody ever see this video, and that is that I've said a couple times like sound quality is more important to me than the loudness, and then I build some stuff that's maybe questionable in quality, and I totally get that. And what happened was that I just kind of bought some stuff, making some assumptions, and then it turns out those assumptions weren't right, and to correct it I would really need to buy new stuff, but I didn't want to spend more money that way, and so I wanted to use what I had. I didn't want it laying around, even more stuff, and so I kind of went down a rabbit hole and wound up having to make a few compromises. And I've listened to it and I think, yeah, it's not the greatest, you know, but it meets my criteria for a Bluetooth speaker. I don't think people usually expend super high quality out of a Bluetooth speaker. And so yes, I do understand it's not the best, but I think it's okay, and I'm happy doing it this way. And ultimately, when you're building something like this, it matters what it sounds like to you. And if you're okay with sort of this level, this is how I built it, and I think you could build it this way too. So given that, sometimes I didn't know whether or not what I was doing is recommended or not, and I didn't have a strong opinion one way or the other. So I had to look up how to do it, which means you do have to have a little bit of technical knowledge, right? You do have to know whether or not the batteries can handle the power that's necessary to run the speakers, or else they might cut out, or you might just have a 5-minute battery life or something like that, which is why I'm doing some of this stuff. And also, you need to match the speaker impedance to what the amplifier is capable of providing, and that's why I use resistors. And I'll explain that here now, just a little bit of technical knowledge. But I don't want to go too wild because you really can get into all kinds of DSP and equalization curves and contour curves and frequency responses, and I mean it just goes on and on and on, right? So I'm just going to explain a little bit of the stuff that I've done, and I hope it helps somebody out there. So I'm having a bit of trouble with the local wildlife lately. This bird has gotten into the garage, and he doesn't seem to be able to find the two ginormous holes, the 3 car-sized holes in the garage. I assume he'll figure it out eventually. I don't know, I think he doesn't want to get near the ground because I'm down here. But let me show you the other problem I'm having with local wildlife. Last night when the air conditioner came on, I heard a huge ruckus out here. And if you look carefully over there, you can see the fins are all kind of totally messed up. All around here they're all messed up, and if you look right there, you can see why. Yep, that's a snake that got in there right when it turned on. And so now I'm waiting for the AC guy to come and see how much damage was done. I created this little setup to do a few things. One, I wanted to make sure that the tweeters were both working, that the speakers were both working, that the unit was working, both channels, and more importantly, to check and see what kind of current I draw when I turn this thing up to a volume that I'm comfortable with. I want that plus a little bit of headroom and I'm good to go. I'm having some problems with that, however. I can say that both tweeters work, both speakers work, both channels work, and it connects to my phone right away, which is kind of nice. But I'm having trouble measuring the current. So what I did was I just used a very simple equation, P equals IV. And if the power was 50, and yes, I know it won't be exactly 50, but I'm taking sort of the worst case scenario here. If it were 50, and in this case the top power supply is 14 volts, then I get something like 3.5 amps. That's a lot. I know that I'm not going to turn it up full blast because it's just going to distort anyway, but I thought I might be drawing maybe 5 or 10 watts and I should get a value somewhere around there. So that is too much for this bottom power supply. Well, you can see that. It only goes to 750 milliamps, so that's why I started with a 14 volt supply that I use on car stuff. I ran it through my multimeter, and even though that is a constant voltage source, it's not a constant current source. So what I found was that as the music was playing, the current was jumping around. A multimeter is not the best thing to use to measure a current that's jumping around, but I was hoping I'd still get kind of an idea by looking and see if I could find some kind of a max. And I never saw it go over, really kind of near an amp. That was about it. And that was turning it up so loud I couldn't really handle it. So that doesn't seem to quite make any sense. What I did to try and stabilize that was I played a test tone through my phone, and I downloaded an app I can show you later that will do that. And I turned it up to a point that I thought if I were going to listen to a tone, what would I listen to, what level would I listen to it at? And that seemed to stabilize the reading, but I was getting like 100 milliamps. So 100 milliamps is 0.14 watts. So I understand that a lot of amplifier manufacturers overstate their wattage, but 0.14 seemed just way too far off from 50 watts that I think I have a case of being smart enough to realize that I'm stupid, and only this time I don't know how I'm being stupid, so leave it in the comments and let me know. Right now though, let me show you how how it works so far. So I have this program, and it's called PA Tone. I will show you what it looks like. Hopefully you can read that. Along the left side here are some discrete tones that you can just choose to play. You can turn the sound on and off at the top, and you can adjust here to make it play anything in between these. And you have choices: the sine wave, square wave, bopper, I'm not really sure what that is, and noise. Square wave is a good tone to put in because square waves have all the harmonics in it, so you'll actually get, it's actually a pretty broadband signal. But I wanted something continuous, so I picked sine wave. And let me see, I think I'm ready to go, so let me just try that. There we go. So I have no idea what, no, that's 5,000 hertz. And that's about as loud as I would want to listen to it at. I don't know what that's coming through like on the camera, I apologize. So if you look in the back here though, it's showing 65 milliamps. So now I'll go to 2700, 66, it's not bouncing around either. 900, I'm getting 68, 300, 65, 100. You can't hear 100, and that's because it's too low. But I can actually feel the table vibrating, which is kind of funny. Well, I can't hear it, but I know that hearing goes as you get older, which really sucks. What I'm going to do is I'm going to start turning it up a little bit. So I've got 65 or so milliamps. You can hear the beeps coming through as I up the volume. And you can even, now I can hear the 100 hertz hum. Here's 300. That's very loud. And I'm at 300 is about the loudest. So I apologize for that. So the test is somewhat successful, I guess. Hang on a second, let me calculate that out. Okay, that voltage supply is set at 1105, so call it 11 volts. And at its max I was drawing about 445 milliamps, so that calculates out to about 5 watts. Well, that's a far cry from 50 watts, but I'll tell you what, if 5 watts does that, I don't need 50 watts because that is really loud. But it sounded to me like the power supply did start to give out at one point, which means it was over 750 milliamps. But that was so loud. Bottom line is, I think the batteries are going to be just fine, and I think they're going to cause less noise. So I'm going to call this test a success. So one of the things I wanted to get an idea of is how much current it draws when it's just waiting for my phone to connect. And that's not good news. It's 45 milliamps. That's how much power my wife's car draws when it sits still in the garage. So I have a feeling at that rate the batteries wouldn't last very long. So I think the idea is it actually has a power button. And of course I have a power button that I'll be using, so I think I'm going to have to just hit the button to turn it on when I want to use it in order to preserve the batteries when it's not in use. I measured my tweeter at 4 ohms. The amplifier wants to see an 8 ohm load, so I bought a 4 ohm mid-range speaker, hoping to put them in series like this, which would generate the 8 ohms necessary. But what I failed to consider at that time was that the speaker came with a little capacitor attached to it. And the reason is that a capacitor acts as a high-pass filter, sort of like this. As you go up in frequency, it allows the frequencies to go, high frequencies to go through, and it doesn't allow the lower frequencies to go through. And this is for 2 reasons. In reality, it'd be more like this dotted line here. Nothing's perfect, of course. But this happens for 2 reasons. One is that if you pass high frequencies through a low frequency speaker, they're usually a lower amplitude and they're moving fast, and that's not good for a big speaker to try and push. But because it's made for much higher power levels, it usually won't damage it. But if you do the opposite and put low frequencies at a high amp, high current, through a tiny little speaker and try and move that much, it'll very quickly blow up a little tweeter. So I think this is also for protection, as well as this, what they call a crossover effect, where you're just limiting the high frequencies to the high frequency speaker. So what I failed to consider was that that capacitor is right here, and when it's in line with the tweeter, it's also in line with the mid-range. So in my circuit, I effectively high-passed everything. So there's no real reason to even have a mid-range speaker if you're only going to use it for the high frequencies, right? So what I thought I'd do to get around that would be simple. I would just put the 2 speakers in parallel like this, and that way the high frequencies would go through here, but the low frequencies wouldn't because it's got the blocking cap. All the frequencies would go through here just fine because it's a full range speaker, and voila, I'm done. The only problem is that now I have 4 ohms and 4 ohms in parallel, which is in fact equal to 2 ohms. That's even outside the range the amplifier says it could handle.
What I've decided to do then is to add a 4 ohm resistor here, and I only bought a 4 ohm resistor here, 4 of them. That puts 2 8 ohms in parallel, which is equal to, 4 ohms. It's not the 8 ohms that I originally wanted, but it's within the range of the speaker, so that would work, and that's essentially what I've decided to do. And I bought some high quality audio quality resistors for that purpose. Now, a guy in the forum said he was a little bit afraid of resistors. I'm not sure why he would be, but now I kind of am too. I think maybe he was afraid because resistor's really just going to waste power. The power's going to go through there and serve to heat it up, and of course heat causes noise, so maybe that's what he was afraid of. But some speakers are available in both 4 and 8 ohm versions, and I wouldn't be surprised at all if the way they got that was just to add a resistor to it. It probably shouldn't. A good speaker manufacturer probably shouldn't do that, but I would not be surprised if that happens all the time in the industry. But this is the way I intend to do that. Given that scenario, I had a couple of options. I could try and boost the resistance or the impedance of the circuit up to a good 6 ohms by putting one resistor in line with both of them, which would give me basically a 4 and a 4 in parallel for 2, and the 4 it's going through and through series would give me 6 ohms. Or I could put 4 in line with each of them, giving me 8 and 8 in parallel, or 4 ohms. I wasn't sure which one would sound best. I assumed it would be this one because it's closer to the 8 ohms it wants to see, but I decided to try them both. So the first test I'm doing is this first configuration where there's just a 1 4 ohm resistor in line with the 2 speakers in parallel, and I'm just going to listen to it and see what it sounds like. And I'm going to go ahead, I downloaded some royalty-free music, basically just the first song that came up, and as it turns out it was a pretty decent song. I mean, it's not my kind of music, but I think it would work well for testing speakers. There's some soft spots, there's some lyrics, there's some more active stuff going on there, and actually it seems kind of like a pretty good song for people who might like that. It sounds almost like something you listen to on the radio. So let's start by listening to it. I guess I have to turn off the Bluetooth. Let's start by listening on my phone and see. I don't know how good the the microphone on the camera is going to be, but here's the song. Now let's just rewind it. I'm going to max it out so you can even hear it. Okay. Now I will switch. Now I'll switch to this little guy. Should switch here in a second. There we go. So I know you can't get the quality of the sound through the camera, but you can at least hear the differences, right? And so this sounds, I think, better than that because it's got just a little bit more bass, which isn't saying a lot considering how tiny the speakers must be in a cell phone, right? Now let's try that guy and see what he sounds like.
Okay, so I think even on the camera microphones you can hear the slow step up in sound quality between these three devices, and that's kind of what I was looking for from a Bluetooth speaker. So so far so good. I thought I heard some distortion with these things earlier, but I mean, my enclosures are really horrible, as you can see, and I didn't have these actually on, and I think they were sort of rattling around or something. So I'm gonna try the other configuration and see what happens with that, and play around with this a little bit. And I might do some measurements with the microphone. I'm not sure they'll really yield any useful results, but the purpose of this video really is just to do the electronics, and so I hope it's not too disappointing if no Bluetooth speaker results from this video. But very shortly, I've already done most of the work on the actual enclosure that this stuff's going to go into, and so pretty shortly after this there'll be a video out that will show you the actual Bluetooth speaker with these guts. My recommendation would be to use the proper impedance speakers for the amplifier that you're using, but if you need to use resistors like I'm doing, then you need to make sure you get the right kind. So on Parts Express they sell these. They're very precise. You can even get them in very small increments. They're big enough to handle enough power. These can handle 12 watts each, and they're non-inductive, so they're purely resistive, or as close as they can get, I guess. If they were inductive, then it's going to add some of that high pass, low pass stuff I was talking about earlier, and you don't want that. It's going to basically change the system. So yeah, just a note. Alright, so here it is in the other configuration. Let's see what happens. So I can already tell it's a little bit louder, which makes sense. 4 ohms versus 6. When I say no, it's yes. I'm putting you to the test. Can you handle me? Do you have the key? Sorry that I've been playing games. Do you really have what it takes? I guess so, I guess so. I guess so, I guess so. I am a queen, I need my king. You better know the Okay, so I tried to bump the bass up a little bit, make it sound a little bit better, and I think that might work at lower volumes, but I was actually starting to detect a little bit of distortion there. I don't know if you could pick that up or not. But overall, honestly, I'm pretty happy with either one of these designs, and I don't know why the guy was afraid of resistors, but again, you know, if you're an audiophile and you're going to nitpick every tiny little thing and make all your Star Trek type measurements to see if it's putting out the exact right tone or whatever, then yeah, you may have a problem. But I'm satisfied with this. I doubt I'm ever going to listen to it that loud anyway. Alright, so to my surprise, it almost seems like the lower ohmage configuration was a little cleaner. So I'm kind of surprised about that. I would have thought that getting closer to the 8 ohms that it wants to see, you know, would have been better. Now I'm going to do some test tones and see what kind of power draw I have, because I assume it's going to be a little bit more in this configuration. When I set out to make a Bluetooth speaker, I naturally went to the internet, and I went to a channel I like quite a bit. It's called DIY Perks. Now, he chose the other method to make his Bluetooth speaker, where he had a separate Bluetooth module and a step-down converter and an isolator and so forth. He says it gets better sound quality that way, and if that's true, and you want to do this kind of thing, you might choose that method. And he also made what are called power cells to power it. He took lithium-ion batteries and he made them into special cells he could kind of plug in, and it was a pretty cool design actually. But it got me thinking, like, well, how am I going to do my power? I mean, that's all I really need, right? Speakers, power, I'm done, which is great. So originally I thought, well, I could do lithium-ion batteries, but I kind of wanted to include a charger. Some people have it so you could plug the entire Bluetooth speaker in and charge the batteries that are there. So I started looking into how you charge lithium-ion batteries, and this kind of opened up a can of worms. So by a can of worms, what I mean is I needed a power source, obviously, for my Bluetooth speaker. So my first thought was just to use batteries. But the problem with the batteries is, even though I could maybe get to the voltages I need, somewhere between 8 and 24, with it preferring to be up toward the 20-24 volt range, with just say 2 9-volt batteries, I couldn't get anywhere near the current I needed. I'd have to stack a whole bunch of those things up, and then of course when they died I'd have to throw them all away and buy a whole bunch more. So I like the idea of rechargeable for something like this, and my mind naturally went to lithium-ion batteries, which is the sort of current technology in batteries, right? But when I started looking into like how would I recharge those, I was hoping to just plug the thing in and not have to take the batteries out. And what I found was that if you get a raw lithium-ion battery and you overcharge it, it'll blow up and destroy the entire planet. If you let it get too low in charge and then try and charge it, it'll blow up and destroy the entire planet. If you short circuit it, it'll blow up and destroy the entire planet. And if somehow the guts get exposed to oxygen, it'll explode and destroy, yes, the entire planet. So obviously you need some kind of protection circuit to keep any of this stuff from happening. Most lithium-ion batteries actually come with one attached to each individual cell, although it is possible if you want to, say, harvest batteries from a laptop to pull out batteries and find that they only have one protection circuit for each cell in the entire pack. So you need to be a little bit careful with that, careful with the choice of lithium-ion battery you choose. And the problem with that is if you go on Amazon or eBay, it's very easy to find fake batteries and copycats, things that don't produce the kind of power they say they're going to produce. Perhaps don't even have a protection circuit when they say they do. They often claim to be green. So if you look around and you do enough research, you'll find out this is actually a thing. And I started thinking, maybe, is there not some other choice? Something, I've seen rechargeables everywhere, lithium ions, are new, but the technology isn't new. So I found these. These are nickel metal hydride batteries. So they only briefly predate the lithium ion battery. And the good news about these is they are much less expensive. Actually, the cost comes out, I've found, maybe about the same, because each one of those cells produces 1.2 volts, whereas the lithium-ion battery produces 3.7. So it takes more than 2 of these to make one of those, so you wind up buying more of them to get the same voltage. The good news is the energy density is pretty close. So even though it's in the same form factor as a AA, which I like because you can get standard stuff like this and use it just like you would with a normal battery, it still produces enough energy to run something like my Bluetooth speaker. In fact, there's way more than enough current there. I need more batteries to produce high enough voltage. So that's the way I decided to go, mostly because I kind of made a miscalculation. I hate it when I do that. I thought 8 batteries would give me 12 volts, and that would be fine. I bought 16 batteries, which would be good. 8 batteries to run it, 8 batteries to charge, and I can just swap them out, charge the 8, run the 8. And that's when I found out that I had actually calculated that based on a normal battery, which produces 1.5 volts. So 8 times 1.5, if you do the math, is 12 volts, and that's what you would get. Nickel metal hydride batteries are 1.2 volts per cell, which gives me only 9.8 from 8 cells. A property of nickel metal hydride batteries is that once you start using them, they almost immediately drop a little bit. And a good thing about them is they stay at that level almost to the point where they die. So it can be difficult to determine how much time you have left in the battery because it's so constant until the end. But that means that my 9.8 volts may be actually more like 8 volts. And if I'm at 8 volts, I'm literally at the bottom of the range of what my amplifier needs. So I was starting to think lithium-ion batteries might have been a better choice here. However, I do like them because they are cheaper to buy. So if if you ever let a lithium-ion battery get low enough, the protection circuit won't let you recharge it, and then you'll have to throw it away. So I'm still happy with my choice here, but I'm starting to think now I may need to use all 16 of these things. I mean, I could go with something less than 10 or 12 to get just to boost the voltage a little bit, but the way I see it is my charger only does 4, and a good charger, which this one's made by Panasonic for the Panasonic batteries, only comes in 4 place, not like 8 place, which would be convenient to put all 8 into. I did buy a second one that gives me 8, but if I'm using 10 batteries, I charge 8. I got to pull them all out and do a second round of charging to get a full set. If I'm going to do a second round of charging, I might as well do 8 and 8 and get all 16 and have plenty of voltage. And with that much current, I have a feeling they'll last a longer as well. So that's my choice. And that's what I'm going to do. So I bought more batteries, so that did increase the cost.
But now I'm going to have like 16 that I'll be charging, 16 that I'm using. And I'll show you how that works. Okay, I have excellent news. I actually put 8 batteries into the Bluetooth speaker system and listened to it for many days, 5 or 6 days while I worked on cars, and I tallied up the hours and it came out to a grand total of 14 hours of use. But that was sort of on off, and if I had to guesstimate, I would say at a reasonable volume that I would listen to out there, I got 12 hours of continuous use. So I only usually listen for maybe half an hour at a time with a Bluetooth speaker, so I think I'm really happy with that, and that's good news because I get to just use 8 batteries instead of 16. So I've said it before and I'll say it again, I'm not an artist and I'm not really very creative. When I started this, I still had no idea what I wanted it to look like. A real artist or creative person would have known immediately, but when the world is really open to me, I have no idea. So I started thinking about it. I thought, well, what do I like? And I started narrowing in on a couple or 3 things, and they're all sort of overlap a little bit, I think. So one is Art Deco. I've always loved that look. Steampunk is another huge one that I really like. And if you're familiar with the game Fallout 3, Fallout 4, it has this sort of retro 50-60 style stuff going on, and I noticed a lot of design elements from Art Deco carry over into 50s design and 60s design, and even some of them into steampunk. And so I'm kind of thinking on somewhere along those lines, but I haven't totally decided yet. So right now I still have a little bit of work to do electrically, and so I don't have to think of that all right now. However, I do have an idea for the next Bluetooth speaker, and I'm totally stoked about it. But it's going to come second because I want to try one with the tweeters first, and that one probably will just be a single speaker. Anyway, that's it. I think I'm going to move on to the next topic. All right, that's the end of the video. I just wanted to make a quick summary, though. With these boards, all you really need is power and speakers. I think I covered the speakers, my decisions there, and the whole bunch of those measurements that I made for the power, just in a nutshell, was essentially, how do I know how long these batteries are going to last? How many do I need? So that's what all that stuff was all about. And if you have another method, or if you could plug it into the wall or something, you could avoid all that. So sorry for the length of this video, but I've got some ideas on how to shorten them. I'm still working on it, and thank you for watching.